Hello everyone, welcome to our first webinar, What is the Design Challenge? I would like to make you aware that this webinar is being recorded. There will be a Q&A session at the end of the presentation, and if you have a question, please could you put it in the Q&A box. If you can't see the Q&A box, you can type it in the chat. We have a new FAQ page on our website, and we will update it with your questions. I'll be handing over shortly to our IMechE Design Challenge Chairman, Davide Migliorini, who will take you through some key information and learnings, after which we welcome Bridget Ogwezi, our industry liaison expert from Ansys, who will take you through the Ansys Simulation Challenge, and we shall finish with the Q&A. Thank you.
So good morning, everybody, and welcome to the Design Challenge. This is our first webinar for 2024, where I try to summarize what is the Design Challenge. I do apologize, Bridget. Could you please, I cannot flick the slides. Could you please move the slides? Thank you so much. Apologies for the glitch.
I'll start. This is, all right, here we go. Davide, would you like me to move the slides for you? I can do that.
Yes, please.
Okay, this is the second slide, so you're good to go.
It's not changing from my side. I don't know if you can see it from your side.
Yes. Alice, can you check that you can see that? I can see how do the students learn. That's what I'm seeing.
No, we are just on the cover slide.
Oh, okay. Hold on.
Apologies, everybody. We will get this sorted out. Ah, yes. We can see how do the students learn now.
Okay, that's fantastic. So this is how the students learn. So the purpose of the Design Challenge is try to give them the exposure to a small but a project that looks like what is done in real world. So they need to put together a different skills, a different knowledge, and a different people to create a proper cross-functional team. It's really an example of how you develop a program in industry. Next slide, please. So an example of how the Design Challenge is really close to real life in industry is the use of the regulation. So if you imagine you are competing for an industrial product where you need to have different companies bidding with a project for something, that is one of the core things of the Design Challenge. So you have a set of regulation that will tell you in general what are the requirements, and then you have a specific project specification. It's more like the technicality of how the project should be done. We encourage all the students to read those documents. They are not huge, and they are quite descriptive with the schematic and other stuff. So they are, approximately 38 pages with the general specification and 20 pages for the project specification that will cover the 3 categories that we have introduced this year. Next, please. So in 2024, we have restructured compared to the previous years the Design Challenge in 3 categories. So the concept category is where we ask the student to do all the virtual activities. So do the planning, do the design, do the calculation, the performance, get through the presentation, but not build the prototype. This has been a thought already present in other competition like the Formula Student. The foundation is pretty much the same as the concept design, but when student could build a physical prototype. In both these categories, we request the student not to plan to use any programmable electronics. So devices like Arduino or Raspberry or anything like that will be classified as programmable electronic. If somebody wants to go for the extra mile, so they are happy to use a programmable electronic, that is for the advanced category. Now, we are always open to discuss about, clarifying a program or a project before it's submitted. So please remember that the Design Challenge Committee and the IMechE are always available for you for questions. Next. Thank you. So some student in the previous year asked us, how could I be effective in my time management? Now, this is just a recommendation. You don't need to follow this guideline, but it's just to give an idea of how much time you could spend or you could put in different phases of the program to achieve the final outcome. In this example is referring to splitting the time where you are building a physical prototype. So you have a number of time that are dedicated to the build phase, the testing, and the validation of the activity. Now you could see that a good portion of the design challenge is still, and is the history of the design challenge, is still focused on building the prototype. So there is about 40% plus some time for the wrap up and on all the other stuff embedded in the physical part of the design challenge. Again, up to the student and up to other universities to split the time differently if you wish to. This is what we thought it was a good guideline to help you. Next, please. For the categories where you're building, so the foundation and advanced, sometimes we were asked the question, where is it value added to build? Now, one of the things that is happening in the world in general is that we are trying to be more conscious about our environment, more conscious about how we use our resources, and as such, use less of our resources. However, the physical part of the build cannot be replaced by only CAD exercises and virtual exercises. So there are a number of examples where it is a wise decision to plan to fix a problem or to evaluate a solution by build. One is that if I could simulate with a basic principle, with basic calculation, then I would not recommend to build something to achieve something. So for example, it will not be a great use of time to build different gears if I could calculate which gear ratio I need. But what it could be, a good example is building different design for the same gear ratio so that I could see which one fit better. That difference could be the key. So something that I cannot simulate. I know that I want that gear ratio, but I cannot simulate easily which design or layout of gear I could have to achieve that solution. Another one is that if I risk to consume too much time in doing all the virtual world analysis, that is better to highlight that activity or that part of our project as a risk and move it into the physical build. So you build with the purpose of clarifying something. Please, next. Thank you. So some key learning that we are trying to encourage with the design challenge and with the presentation of the design challenge is first one is try to design out a problem. So if you believe a solution is not robust, try to understand how what is the robustness required for that one, and then try to put in place before you build something that you're happy with. Another thing which is quite interesting is that most of the students, if they are at their first competition, they don't know where to start from. Now, the ultimate goal is provide a device, build a device. A physical device will be characterized by an envelope, by a mass. That mass will require some energy to be moved. And as such, you can start your initial calculation with a mass, an acceleration, a time, and check if you're within the scope of the competition. As soon as your design mature, you have a better visibility on the mass, you still have your boundary on your other stuff, and then you carry on. So starting with an assumption is a very powerful activity that students could do. They don't know where to start. Effectively, make a guess, and then develop their calculation and develop their understanding, while the guess is more realistic and less hypothetical. Something very important is managing the BOM. Now, it is boring for students to understand the concept of the bill of material. It is a real life and a real industry requirement. When you build something, you need to buy every single bit that you are going in the build. If you don't have all the detail, you cannot ultimate or finalize your build. If you don't know what you're putting inside, you don't know how much it's costing you, so your business will not be profitable, or it will not offer a competitive product to your final customer. Then we'll look into a couple of concepts that with some extremized example, talking about the verification and validation, and what is the design for durability, and then the concept of robustness. Next, please. So, how does the BOM help a student? Is it normally something where the student don't spend too much time on, and they may not understand how it could help them. Now, why should I have a bill of material? Well, to decide if I need to design a component that will build or manufacture in the university or the college facility, or if instead I could buy them as off the shelf. For example, I'm not suggesting to build your own screws. They could be bought from a third-party supplier. How? Most of the CAD software will help you in creating a 3D model and extracting automatically a BOM. So the better is your CAD, the better is your BOM, the smallest time you'll spend in building your device, because you can order everything upfront. What and how I should work with my BOM. If you please look into the design challenge general spec 2024, in the section 6.6 to 6.25, there are details on what should be included in the BOM to help you get in at the end and understand how much your device will cost, and how many components you need to do yourself, and what instead you need to buy them. Where am I listing the BOM? How am I presenting the BOM? So Appendix 1 has some picture that show you how you could organize with your own Excel file the minimum information required to go through the BOM submission and the BOM analysis. We hope that by looking at the picture and by building the file yourself, you will get a little bit of learning and that ownership over all the components that you need to procure, what to prepare for building your product. Next, please. A couple of concepts here that, at least when I was a student, I was not really shown or explained. They were not really shown or explained to me. So things that you are doing in the design challenge and that we'll do in an engineering life are the steps of verification and validation. So the verification is that prove that your design meets the requirements. In this case, the requirements are the regulations. So the question you're answering with the verification is that I can design something which is a fit for the purpose of the design challenge. The validation is that prove that the requirements were met and were accurate. So when I build my product, so that we start to have into the physical phase, my product does the job that was specified. Now, something which is sometimes a little bit overlooked is the difference between durability and robustness. So the durability is that you know that your product needs to do emissions, so it needs to do at least a regional final, which is be composed by a number of it, and then eventually a national final, which is be composed by a number of it. You may decide that you want to do a number of other runs to check that your device is okay. So that is your durability. Your product should be able to do a number of cycles of the mission before falling apart. And ideally, you want your product to fall apart after you finish your mission. The concept of robustness is a little bit broader. So now, ideally, you would like to have your product that could do the job, so could do the cycle with different users on different surfaces in different locations. So you are not really too subjected to the friction of a specific board that you're testing on. If you're talking about the 2024 device, you're not really linking the functionality of your device only to one team member, So you don't have only one operator that restricts your capability. So the robustness is, am I capable of doing the same job as above as many times as I need to do with the broadest possible environmental and user condition that are there. Next, please. Now, please, these slide and the following one are specified to have a little bit of a laugh. So the products that you're seeing there at high level are designed for these conditions. So let's start with a very old, the first series of Fiat Punto. The design life was approximately 7 years and 65,000 miles. Compared to an equivalent age Toyota Yaris, the design life for that, effectively say competitor like-for-like product, is about 8 years and 70,000 miles. Both will require a very basic level of user. So pretty much anybody with a valid license should be able to drive it in any country the product is sold. If we compare it to a Formula 1 car or an airplane, the condition is completely different. So while for an airplane, the design cycle is approximately, I would say, 30 years or a number of hours in flying or a number of flight cycles, whichever comes first. And pilots need to be specifically trained. So you don't fish from all the pool of pilots that could fly, but among these pilots, only the one that do a specific training academy and training process will be allowed to fly that stuff. At the same time, only a very bespoke set of technicians and operators could do the maintenance of on this device. If you go then to extreme of a Formula 1 car, for example, the design life of the car is, let's say, approximately 22 races with an average of 600, 700 miles per each weekend. The vehicle needs to last 1 year. Per each driver, you normally get 3 power units, and normally you have only 2 drivers that start the year and finish the year. Only a number of technicians will be allowed to do a number of operations, so it's very, very restricted. If we apply this in terms of durability and robustness, what does it mean? Next slide, please. So the Fiat Punto has been considered in the UK one of the possibly worst vehicle sold. In reality, with very, very minor maintenance, it could last easily 9 years. This is, with the brackets and with the laugh, please, is a bad design example because it's exceeding the design life. Now, in reality, is that with very little maintenance, with a lot of passage between different people with relatively low care, the vehicle could outlast the design area. So robustness-wise, is a very robust product. If we look into the Toyota Yaris, is even worse than that in terms of design. So while the car was designed initially for 8 years, it's not uncommon to find in good condition vehicles that are 18 years old, with the same kind of level of lack of maintenance or lack of care or different kind of things. If you look at the Formula 1 car, then the concept of durability is incredibly good. So if the car, for any reason, hit one curb more than what was designed to, the suspension may fall apart. So the car is really designed to the extreme, and the components are really designed to the extreme. Reality is that the robustness is very low. So sometimes if you change a mechanic which has not been trained to do the job, or even worse than that, you need to change your driver, you may have a failure that previously you were not encountering. Going into the aerospace example, as you can imagine, for different requirements, nobody wants to see the vehicle, the device to fall apart because it is in the sky. So the durability is somehow unknown. So the vehicle, in this case, the plane, is taken off service whenever you reach one of the design conditions without really checking if it could do other stuff. Again, this is an extreme case, an extreme example, but just to make you think about that one. Robustness, similarly for what is the Formula 1 car, is not great because all the maintenance needs to be done absolutely specifically only through bespoke training center, trained people using only approved replacement parts and only within a very strict control. So you may have a different opinion now of what is durability, what is robustness, and what is a bad car, for example, on the English market. Next, please. So here is, I anticipated a little bit before what we're going to talk about. So if you don't have any starting point because your university or your college is the first one trying this challenge, you may not have any starting point. Now, making assumption, it really empower the team in developing the design. So if you don't know where to start from the basics. So read the documentation. The design challenge is asking you to produce a physical product. So what are the characteristics of a physical product? Each physical device will have a mass and a volume. You could assume a reasonable value. Then based on that mass, you could calculate how much energy you need to move this mass, how much energy you need to accelerate and return it back. You will be able to calculate the speed and the time to perform your profile. That will give you an initial value. Now, the mass applied onto the ground, in this case, we're talking a vehicle that moves horizontally, will develop some friction with the wheels. This is the maximum torque that you can transfer onto the ground. That will give you the first input on sizing your motor. Now you have a number of data that will help you to decide which motor, wheel size, and the gear reduction you could possibly have. At this point, you start to have some data starting from an assumption that will help you develop in your CAD. Your CAD will give you some output, which is a new mass, and then you could enter in your calculation the revised mass to see if for any reason you have a different result at this point. Now, the more is detailed your CAD, the less surprises you will have when you build your profile, your prototype. So please be mindful that working in the virtual world, so in a CAD world with a lot of accuracy, is beneficial because it will help you to control the time that you spend in building your prototype and the cost that you need to put together this prototype. This is a loop. So you start from an assumption and then you verify if your assumption was correct or not. Then you update your job, and maybe over the line you discover that actually you need a less powerful motor, or you could benefit from a different gear transmission. Having this loop will help you in material design, even if you didn't have any inherited design to start from. Next one, please. So something that we tried to include in the general specification was the concept of the penalties. Now, please spend your time in going through the IMechE Design Challenge general specification. There are a few areas there that are important. The first one is that we kindly request all the documentation to be submitted 1 week before the event date. That is explained in section 1.3. What happens if you are late? That will be considered as an unfair advantage. So there will be a penalty as detailed in the IMechE. The same thing is that if you spend more than what is in bond, again, it could happen. And it could happen that some teams get out with a very clever design where they use way less money than what is allowed. We need to appraise the teams that did a good job with less money than what was there. So as such, being over budget will be considered effectively an unfair advantage, and that is why it will be penalized. Now, another question that could be asked or could happen when we are in the final is, well, our team won a section of the challenge, but we didn't get the overall winner. What has happened? Well, if the team has won one of the section, but it didn't submit completely all the requests, their score will not be used to do the cumulative score and calculate if they're the overall winner. So please check in the general specification, section 16.17, what that means. Next one, please. I now handing over to Bridget for the sponsor award Ansys. This element of the competition is outside of the general competition, so it's not included in the mandatory steps, but is a very good opportunity to interface with the industry representative. In this case, we are happy to work with Ansys.
Davide, thank you very much. My name is Bridget, and thank you all for listening so far. So we're introducing this, like Davide said, that's something that goes alongside the actual competition. It's not mandatory, but if your students want to get, or if you want to get some extra skills in simulation, we're giving a chance for you to do that. So it's a very simple thing. It's meant to be a very easy lift, nothing too much extra on top of what you're already doing for the design challenge. So the first thing we'd say, if you don't have access to the tool, Ansys tools, there's a free student version, and there's some links here that we'll share out with you later. Get access to Ansys and download it, and you can get that for free. The next thing is you've got your CAD model, you've designed it, so import that CAD model into the simulation tool. And the actual work for you to do here is to take one aspect of that design, just one thing, just one part. And I'll show you a quick video here that gives you an idea of something that can be done. It's meant to be done in quick time. Hopefully I can get it to run fast enough. Okay, so the idea is you take one aspect of your design. In this case, we've taken a hook that's load bearing, put the boundary conditions on it, and done some assessment on it. How much, what are the stresses, what are the strains that are on that? And then thinking, based on what we have and the factor of safety, can we reduce the amount of material to make it lighter? Can we do something like that to make the entire component lighter and make it more efficient? And so very simply, we can do that. You have monitors in the tool that help you see what you're doing as you're changing things. I think I've got to the end of that quite quickly, but that's the general idea. Can you take one component of your design and optimize it, make it lighter, make it change the material, and then see some improvement in your final product? So I mentioned there's some useful links, and when we send out the slides later, you'll have access to how you can download the software that I'm talking about here. We're recommending a tool called Ansys Discovery, which is really easy to use for designing. If you're just getting started with Ansys, we have hundreds of teaching resources available to do that. And of course, you'll have access to this video in real time in the 3-minute version that you'll have access to when we share the links with you. So for the simulation challenge, this is what we're saying. We're saying it's open to everyone. Anyone in all the classes can do that. And it's not meant to be complicated. So it's either a structural simulation or a thermal simulation, or you can simulate fluid flow, like how's the air flowing over your device as it's moving, and can you optimize the shape of your device to make the airflow better? We've got some examples here. For a structural analysis, take a component, analyze it. Can you improve the light weighting while maintaining the structural integrity? An idea there. For a thermal analysis, is there something that has a heat source? Maybe your motor is generating some kind of heat and it's affecting some other components in your design. Can you maybe change the material, change the casing or something to reduce that heat, the transfer of heat, and do a simple model on that? For a thermal analysis, like I said, model the airflow over your device as it's moving. Is there something, a shape you can change, something to do with the aerodynamics to make the airflow over it better? So do that simple simulation and then show how you've improved your design. The submission, like I said, is meant to be something not too heavy for you to do, not too much extra. So we're just asking 1 or 2 slides to show how you set up your model. So you take your CAD model, you've inputted it. What are the boundary conditions? What are the stresses you've put on your design, on your model to show what you've improved? We'd also like a 3-minute video, just like the one I showed you earlier, that shows what you've done. So a screen, like a screenshot, a screen recording of you doing the simulation from one step to the next. What have you done? What have you redesigned? And then we'll take the top submission from each regional heat. So just how we do with the rest of the design challenge, the leaders at the regional will come through to the final. But you can update your design as you do with the normal design challenge. You can update it and take an updated version to the final, and we'll reassess again on the final day. Scoring is important, and that's because I want to highlight the things that we'll pay the most attention to. And of course, when it comes to things like computer programs and simulation, if you're not putting the right parameters in, you're not assessing the right things, your results will be completely wrong, even if they look very pretty and they look like you've done a good job. So the highest scores we're awarding for this particular challenge is to understand, have you got the correct boundary assumptions, the boundary conditions? Have you applied your loads correctly? That's the thing. What are the assumptions? And some assumptions will have to be made. It's not a perfect representation of everything you'll be doing. What are the assumptions? Do they make sense? The other thing to pay attention to that has another high score is interpreting your results. So of course you've got like the monitor showing you you've got this factor of safety or this, you know, this level of Mice stresses. What does it mean for your design? What are you changing? And have you actually made an improvement on your design when you've redesigned it? So those are two things to pay lots of attention to. What are the boundary conditions? Have you interpreted what you've done correctly? And of course, there are other bits to look at. What are the things you've used to assess your design? Have you demonstrated some clear design improvement? What are the impacts? So that's what we're going to be looking for in the design challenge. As a reward now, what each winning team member will receive will be Ansys free Ansys simulation certification. Now, on paper, you may not understand what this means, so I'll explain to you. We have certifications that you can sit and you can get to add on to your CV. They currently cost over £300 for each one, but we will offer this to that's winning team for free. And you can sit the certification, get that, it goes on your CV, and you know that once you have those kind of certification, you are commanding a higher wage when you're going to apply for jobs. So it's a really valuable thing to have. Not only that, you're getting a skill that will serve you very well in industry, will serve you well in your final design, your senior design, but serve you well in industry. Not only that, we'll be pleased to feature the winning team on our Ansys blog. We have a global blog that features our companies we work with, but also winning student teams that we work with. We love to feature them to show the good work and the excellent things that they're doing with Ansys. So that's what we're asking. It runs alongside the main competition. It isn't mandatory, but if your students are looking to get extra skills, would like to get hands-on with simulation, and find another way to optimize their design, then please go ahead. All this information is available on the Design Challenge website. It's on the IMechE website. And of course, you can reach out if you have any questions you want to ask us directly. And Davide, I think it's back over to you.
Thank you very much, Bridget. So this is the steering committee that is behind the design challenge. So we are trying to list the people that are there. Whenever you contact through the IMechE design challenge page, you reach out one of these people behind an email address. So we are always happy to help you, and always happy to answer any question. I will now. I think that now we are finished for the presentation side, and we have a lot of time for question and answer. So please, just go for it. Something that we are making again an introduction for the 2024 on the IMechE Design Challenge page. There is a section with the frequently asked questions. So we'll keep updating that one and making sure that every question that is relevant and asked by a team is then available to everybody for consumption. We'll do the same with the Q&A link that is in this presentation. So if somebody wants to write a question, we will answer it and put it on the website for availability of everybody.
Davide, I have a question, if that's okay.
Absolutely.
All right. I'm wondering if you could just kind of run through the different classes that are available this year and how they compare to what was previously available.
Oh, thank you very much for the question. I really went quick on those, and I didn't really expand on. So one of the big structural changes that we put for the design challenge was to remove the boundary or the barrier from first year and second year. At the same time, we introduced the category concept that is historically present in the formula student for university or team member that may have been already putting their finger in the formula student. What does this means from participation? So the first one is that we open to colleges, students from colleges or any other engineering related schools, if people want to attend. So it's not anymore only for universities. The second one is not anymore limited to students of the first year to attend the first year challenge. So students from a college or the first year could attend could participate in each of the three categories. going back to the three category is the basic category is getting a design of a device that doesn't make an advantage or doesn't make any usage apologies, of electronic or programmable device. This base category is a repeatable vehicle for this year that will move from one point and come back from the starting point. The distance could be adjusted on the day of the competition, but there is no repeated movement. So the movement is start, hit a wall, or contact a wall. Apologies for using the word hit, and then come back on the starting point. The vehicle will be scored on the precision only. Now, the design element of how I'm designing the vehicle is the same and is common between the concept class, where the design activity is the wrapping up of the presentation, or the foundation class, where after the design activity, we encourage the team member to build what they designed, test it, and then take it for the physical activity. The advanced class, which is open to pretty much any student, is a similar vehicle, but you could use programmable electronic. The budget is higher for building and eventually providing any spare for this vehicle, and the vehicle needs to do a repeatable task with additional movement. So for this year, it will start from a given point, move toward a vertical wall, impact the vertical wall, come back on the starting point, move forward, stop on a second target point, and then move again forward onto the wall. For this activity, normally students add some visual recognition devices or some ultrasonic sensor, both of them or not all of them, additional batteries. They write their own code to control the motors, or the motors installed, and they have different batteries. Budget for the two classes are different. So the budget is £40 for the concept and the foundation class, and £80 for the advanced class.
Thank you very much.
Thank you, Bridget.
And I'll just answer the question that's right here, whether we'll have access to the slides. Yes, the slides will be made available after this by the IMechE team.
I'm preempting questions with something that has been asked before or in other events. My vehicle broke down the night before. I'm thinking to withdraw. What can I do? Is the night before the event? Answer or recommendation or suggestion from the IMechE Design Challenge. Please attend the final. It may be possible that we help you in getting your vehicle fixed, or anyway, if you cannot do the physical competition because the vehicle is not there, it's still a great value added to any team member to see what other people have done, see how they are managing the problem, and still have a good networking opportunity and a good learning. So please, recommendation is that don't withdraw if things go wrong. Try to put your effort and try to reach out on us, and we'll help you in getting through the regional or the final.
Thank you, Davide. Just to let everybody know, I've unmuted your microphones. So if anybody wanted to speak up and ask a question, please go ahead.
There is a question in the chat for you, by the way, about Mark Williams wants to know, can you use programmable devices for the foundation, or is it only for advanced class that you can use programmable devices?
The programmable devices are only for the advanced class. In the foundation and concept, the programmable devices should not be used. It is the programmable devices is listed in the specification clearly, and at the same time, it may be incompatible with the budget. So it's highly unlikely that somebody could use a programmable device and still fit within the £40 budget to build the full device. Plus, that is expressed as not the preferred solution for the first entry level and the concept class.
Davide, I have another question, and this is based on sort of what you said about if your vehicle breaks down the night before, but they've already entered as in let's say the advanced class. Is it possible to change the class you enter for? Like say, okay, well, I don't have my vehicle. Can I then do something else?
Very, very good question. Now, it's very straightforward. If you enter the foundation class and for any reason your vehicle is not ready on time, so default into the concept class, that will be very welcome and will certainly accommodate that one. If instead your design is all based on electronic and programmable device, defaulting on the concept class where the programmable electronic is not allowed may require a lot of redesign in your device. Having said that, given that the mission profile is simpler, we encourage the student that for any reason don't get to the point of building the physical prototype for an advanced class. If they have done a good understanding of what is the job behind, with some effort, we encourage them to default into a lower class, and we'll welcome and help them in getting through this activity. The main difference is that while moving from the foundation class into the concept will not require a redesign, it's just removing the physical elements, so the physical prototype from the competition. Moving from the advanced class into a lower class may require a bigger redesign, so it may be quite a big effort with the student, and it could be incompatible with their workload at university or at the college.
Thank you.
I think it looks like we don't have any more questions, unless anybody has got a burning question they would like to ask right now. So as Davide said, we do have our new FAQ section on the website, so please refer to that or email your questions through to designchallenge@imeche.org. Thank you for your time today, and that concludes our Design Challenge webinar. Thank you.
Thank you. Goodbye.
Goodbye.
Thank you. Goodbye.